Somehow it's less controversial, though, if we talk about animal diets. And one of the rather non-controversial things we can say about animals is if that we feed them diets that are adapted to their evolutionary needs, their species-adapted diets, then they will thrive. However, if we feed them diets that are not metabolically appropriate, well, then they will get either sick or die. And of course, there's a certain flexibility here, whereby we may diverge a little bit from the evolutionary background to meet certain contemporary requirements. And you can think about feed complements, or you can think about pet food, but somehow there are certain constraints in place. And when we talk about pet food, for instance, I found this interesting coming from a WWF campaign a while ago in Belgium, where the argument is that we overfeed our pets in the West. And because of that, they get obese. And while we're doing that, we're taking away resources that we could use to benefit the wild variants, the big cats in the global South. And the main message here is that our pets should eat less, so they'd be more healthy, and everybody would benefit. Now, the question here is it really the fact that those pets are overeating as such, or is it that the food they're consuming is metabolically inappropriate to them? And of course, pet food nowadays is trying to mimic as much as it can the ancestral types of food that those cats were receiving, but merely correcting for essential nutrients may not be sufficient. And that's what Jörgis Krinis has called also the concept of nutritionism. We're trying to approach evolutionary diets or species-adapted diets by looking at specific nutrients and trying to compose something that approximates it. So that's the step I'm taking coming in through animal feed and moving to human populations. Now, if you look at the ingredient list that you see on this slide, it is pretty much the same impression you'll get from the previous slide. It's food that is centered around all sorts of oils and refined starches and what protein isolates and whatever you have. And then they complement that very often with certain vitamins and minerals. And those types of foods are surrounding us on a daily basis. So in a way, we are surrounded by what technically we now call obesogenic ultra-processed food environments, which tend to lead to an excess in calorie intake. They tend to come with micronutrient deficiencies, and they tend to come with cardiometabolic disease, to the point that Western populations that are surrounded by those environments get in a bad metabolic shape. The situation in the United States today is that only 1 on 10 US adults nowadays have optimal cardiometabolic health. Now, they're not all diseased to the same degree, or they may not even show patterns of disease yet, but somehow their metabolic markers indicate that they're deviating from optimal health. So that means 9 on 10 US adults are now heading in that direction. And that's extremely worrying. So the question is here, is there a way to identify or to approach a certain specific human species adapted diet? Can we do that? Well, the first point is that it's difficult to do so because people are different. People come with different individual needs, and they may have different dietary requirements. And what's more so is that humans are also remarkably flexible. We are omnivores in many ways. And we can see also from ancestral populations, this is a study on the right side here from hunter-gatherers, that there's a whole spectrum of diets that are heavily plant-based, or diets that even are almost exclusively animal-based. So there's a lot of flexibility within our species-adapted diets. There's not no single diet may even exist. That being said, there are some core principles that we should respect and that we should somehow take into account when we want to have healthy diets. Now, another observation is, of course, that our contemporary dietary behavior is very, very different than most of our ancestral history. it's aberrant in evolutionary terms. That doesn't necessarily mean that it's going to be bad for us, but if we look at the numbers, it seems that in a very short time, lots of things went into the wrong directions. So what is the diet that what is the evolutionary diets that humans come from? How did we evolve, dietary speaking, over our history? Now, then we have to go back, of course, to the stage where we moved out of the woodlands, moved into the grasslands, and started to leave those mostly fibrous materials behind us, and started to adopt grassland-based diets. And those diets, they are much more nutrient dense than the diets that other primates still consume today. And they are so nutritionally specific that they also modified us. They changed us. They changed human bodies and they changed human minds, and irreversibly so. Okay, so those high nutrient diets, they came with bigger brains, and they came with a gut system that was more restricted, smaller because of the nutrient densities, and several anatomical and also metabolic deviations are still valid today and are still conditioning us. This is an overview, and there's much more to say here, but there's a clear drop in fermentative capacity compared to other apes. There is a strong adaptation to high protein fat intake. And importantly, there's a reliance on external nutrients that were coming from those nutrient-rich foods, so that the internal in vivo conversion of certain plant precursors became less important because we were getting them from the foods anyway. We lost capacity for vitamin B12 absorption, and so on and so on. So the human savanna diet, in a way, is a very different diet than more ancestral populations were consuming. And we can, of course, given that flexibility and this different ecological zones on the planet that we moved into, we can, of course, play with those conditions and still be healthy humans. But what happens if we deviate too much? And is there a certain borderline where we get into trouble? Now, it's interesting at that point to look at the stage where we really moved away from that ancestral diet to the agricultural diets in the Neolithic that were heavily dominated by cereal staples. And we very typically see that there was a sharp drop in health. And we can measure that because of a number of findings, and we have data to support that. And you can, for instance, look at height as a proxy. And this graph shows you how human height has dropped once we started to adopt those agricultural diets, is at least in the very early stages. And then how throughout the Neolithic and the Bronze Age and further stages, there was an increasing stabilization of animal products. And that went along, or that came together with a recovery of the height. And then in the next stage, which is the industrial age, because of the boosted food availability due to industrialization and due to food technology and all sorts of breakthroughs, then certainly, of course, we got much better nourished. And you can also see that as a very steep, almost vertical line in height increase. So throughout the ages, variations in diets have clearly played on our human development and health. And we have now arrived in a very different era, which is the post-industrial era, that comes with its own specific problems. And those are the ones that I mentioned before. We have people that are overweight and obese, but at the same time, we have people that are hungry and undernourished. And very often, we also have people that are both obese and both overfed, and at the same time also undernourished. Those things can also come together. So in a way, this is a general pattern of malnourishment with many different aspects. And they very often translate into the symptoms of the metabolic syndrome and prediabetes and diabetes and so forth. What you see here is an extract of the Dublin Declaration, which we launched a while ago, where we make the case that for future food systems, we're facing an unprecedented double challenge. On the one hand, we'll have to satisfy those nutritional needs of increasing human populations. But on the other hand, also, we have to do so within environmental constraints. So the methods and the scale of the interventions or the systems that we will apply will be extremely important to also make it sustainable. So that's, to sum up, we're looking for those healthy and sustainable diets. But how will we get there? Now, there's several solutions that have been proposed. On the left-hand side, you see the Eat Lancet diet, or the so-called planetary health diet. That is a dietary proposal that would match both healthy and sustainable conditions. And on the right side, you see the idea of the protein transition, where it is said that we eat too much protein and we should also eat better types of protein. So that means less animal foods and more plant foods. And that's the general paradigm that we face all the time when we look at food systems. Those are the main messages. And Eat Lancet is a high-level profiles report with lots of influence. Notice that Eat Lancet specifically says that red meat is unhealthy, and it's mentioned in the same sentence as sugar. So that's a very different paradigm, of course, than the evolutionary diets that I just described. Now, there's a couple of things we have to maybe explore in a bit more detail. And the first one is that protein transition. So this statement that we eat too much protein in a way that is not entirely incorrect, but it needs much more context. Those calculations and those statements are based on dietary allowances that are recommended, and that's 0.8 grams per kilogram of body weight per day of protein, for instance. That's a typical recommendation and the most common recommendation. Now, however, that is a minimum value. It's a value to avoid lean muscle mass losses and avoid negative nitrogen situations. It is not necessarily an optimal value. Okay, some people benefit from more protein intake. Their optimal health is at higher protein intakes, and that's a considerable amount of people. It's people that want to build muscle mass, obviously, but it's also pregnant and lactating women, elderly, facing sarcopenia, diseased people that are either acutely or chronically ill would benefit from twice or up to 3 times the amounts of recommended protein. Moreover, not every protein is the same. Protein quality is extremely important. So we need to factor in both the digestibility of the protein, but also the amino acid spectrum, the combination and the relative proportions of the essential amino acids. And if you do that, you have to cluster foods in different quality levels. You have the animal proteins that are coming at high protein quality levels, and you have the cereals, which are very poor sources of protein. They have quite a bit of protein, but it's very deficient in lysine. And then you have the legumes somewhere in between, and soy, which is one of the better versions in the plant spectrum. But claims on being a good protein source will very much depend on this state-of-the-art outlooks on protein quality, and it means that many foods that are now considered as good plant sources for protein are not necessarily going to be so when you have a closer look. Now, that is not to say that it's impossible to reach good quality levels with plants. Of course you can, but you need to combine those plants cleverly. You need to maybe also have higher intakes, and it comes with more caloric load. It comes also with more volumes. So it needs a more careful strategy. And more importantly, it may not be suitable for everybody. Some people are not adapted to high intakes of legumes, for instance. It comes with problems of tolerance. And then also you can think about gluten intolerance. If you talk about cereals, allergies may be important, or people just don't like the taste of it. They may not even know how to prepare them properly, because especially beans, they come as toxic products. They need to be cooked well. They need to be soaked. They need several food processing interventions. And I do have a problem also with the way we describe protein. We talk a lot about animal protein or about plant protein as a denominator for a whole category of very different products, right? There's a huge diversity behind the concept of animal protein, or plant protein for that matter. And it tends to overshadow the importance of other nutrients. And using protein so strongly in dietary design and dietary discourse makes us forget about all the other things. And focus is so much on protein nowadays that we talk about protein substitutes, but we are not looking very well at all the other nutrients, micronutrients, minerals, vitamins that would also need lots of our attention because they tend to be very often deficient in many contemporary populations. So putting so much focus on protein and protein substitution leads also to so-called alternative foods that then come with lower intakes of, say, B12 or iodine or zinc or long-chain fatty acids, and you name it. And moreover, it over focuses on protein isolates rather than on wholesome food solutions. And very often those alternative foods come in through a fast food window, like they enter to the fast food culture. You're talking about burgers and sausages and you name it. It's never really wholesome plants, protein types of combinations. If we look at what is being said nowadays, and it's of course also a matter of convenience. Now, but the question that I really want to put forward here is, what if, and let's just ask that question seriously, what if too little animal protein would come with the risk? Because even the Eat Lancet diets suggest that a completely vegan diet would just be fine as long as you supplement with B12. But is it? Now, recent calculations have shown that the Eat Lancet diet comes with too little micronutrients. There's a gap for certain micronutrients, and they looked at some of the major ones, and they find indeed B12, zinc, iron, calcium, and a couple of others are limiting in such dietary setups, and it's difficult to meet those conditions properly. And those dietary frameworks, most of the time, they are also very much theoretical. So let's try and confront those dietary ideas with everyday reality. Now, this graph shows you an overview of meat intake for different countries, right? So you have the countries at the x-axis, and then on the y-axis, you have the meat intake. And the line I have drawn is the suggested intake of meat according to the Lancet diet. So it can be 0, but it can also be the suggestion of 16 kilograms of meat per year. Sorry, that's a mistake. It should be per year, 16 kilograms per person per year. And at the same time, those countries that match the Eat Lancet condition are also the countries where we have extremely high stunting rates in young children. Right? We're talking about 1 on 3 or more children that are severely here malnourished. Now, of course, this is a graph that is, it's showing you certain correlations, and it's not necessarily a causal graph, because there's a lot of confounding from poverty and from infections and whatever you have, but it's at least a warning sign. And you can also see it here on the right graph, where on the x-axis, you have the percentage of kilocalories coming from animal source foods. And on the y-axis, you have inadequate intake of certain micronutrients. And you see that if you look at the Eat Lancet diet, which has 14% of calories coming from animal foods as its key suggestion, then you are really in the zone where you have lots of deficiencies worldwide. And those diets tend to come with nutrient gaps. And the threshold for adequacy seems to be higher and more or less maybe here at around 30%. It's not a fixed number, but around 30% of the intake from animal source food seems to be a more robust dietary composition. Interestingly, the 30% value is also what you find in ancestral diets. This is the graph I showed quickly in one of the previous slides. So this is the overview of different hunter-gatherer populations and the amount of animal source foods they eat. And you see that none of those populations drop below the 30%. Some of them even go up all the way almost to 100%. And we're talking about Arctic populations, of course, where there's there are very little plant options to begin with. And the ancestral mean value would be around 70% of animal source foods if we're talking about caloric intake. Now, what do we eat in Western countries? Well, if you look at the United States, the estimate is that animal-based foods represent around 30% of the calories. So we are already eating a mostly plant-based diet. We are already pushing it to heavily plant-based diets supplemented with animal source foods that are maybe a minority in caloric intake, but they of course represent a lot of nutritional value. And the 30% is not a magic rule here. Of course, a lot depends on the quality of the foods, both in the animal spectrum and in the plant spectrum. So it's don't see it too rigidly, but because quality is also important. Another way of looking at it is that This is a recent study that looked at protein intake, and the conclusion was that we need about half of the total protein to be from animal foods to meet the recommendations for key nutrients. If we don't want to supplement, right? If we suppose we get our foods from our nutrients from foods, and there's a little uncertainty range there because different people have different needs, but that's about the instruction you get. Half of your protein should come from animal foods if you want to have more robust diets, and that's different than what we often hear in the protein transition stories. And mind you, this is not only a global South problem. Deficiencies are very much also a problem in the West, and especially in populations with higher needs. Take the case of iron. Almost half of the young girls in Australia and in the United Kingdom are now having too little iron in the diets. And in Australia, there's an estimate that it's about 8 to 15% of the toddlers, depending if it's boys or girls, that lack sufficient iron. And that has to do, it's ascribed to a couple of factors, but one of them being that young parents nowadays are afraid to give red meat to their children because of all the stories they hear. So evolving diets come with changes in nutritional adequacy, as we can also see here for iron deficiency developing over the last years. And it is not always because diets are sloppy or because people don't eat healthy diets or don't respect the rules. Even when the diets are designed or well formulated, it's not always a given that everybody will react on the same way. On the right side of the slide, you see data from the Netherlands and from the 90s, where there was a wave of macrobiotic diets, and people looked at it, and there were severe problems with nutrients in children. So we also saw that breast milk contained less nutrients. There were growth problems. There were psychomotoric development problems with children. And the macrobiotic diets are diets that are very much like the Eat Lancet instruction, right? They tell you more or less the same ideas for different reasons, because it's a spiritual diet, but more or less the same dietary pattern will be advanced, and it's a whole food, plant-based type of diet. At the bottom of that slide here on the right side, there's a study that comes from Finland where nutritionists have designed diets for daycares, and they saw clearly that children following vegan diets were different than the children who followed the omnivore diets. We don't know what that will mean on the longer term, but there were very significant metabolic differences that had to do with omega-3 fatty acids and with retinol and with all sorts of different markers. So there was a clear impact, even if those diets were designed by nutritionists. It doesn't mean that it's always a problem, and the data is not always very sharp, and there's a lot of confounding and all of that. And it's difficult to make any definite statements. And that's a common problem with observational data. Observational evidence, in principle, cannot be used to prove causality unless you have very, very strong effects. And in nutrition sciences, you need intervention studies. You need randomized controlled trials that would prove your causal implications. Now, that you cannot do that most of the times because of all sorts of reasons. And especially, it wouldn't even be ethical if you would deprive population groups from valuable nutrition by not giving them some nutrient-rich foods and expecting at the same time that it would have a negative impact. So that would be difficult as an ethical intervention. But what you can do, however, is to give animal source foods to populations that have deprived diets. And that has been done. It has been done in countries in the global South. It has been done in Kenya, for instance, where meat was supplemented. And there were remarkable effects on cognitive and physical development. And there are a couple of other studies that show you that there is a clear positive impact when you improve animal source foods intakes in those populations that have difficulties to adequately meet their nutrients based on their local food systems. So that's about too little animal protein. You can also, of course, have a discussion on too much animal protein. I will be very brief here because I don't have the time. But if you look at the large cohort studies, this is on the left hand side, you see an overview of some graphs that we recently published, looking into the large cohort studies that are available. And if you look at those studies, there's essentially nothing to worry about if you have intakes of red meat, which is the one getting most of the blame, because the others are not necessarily even problematic in observational studies. But for red meat intake, there's a safe zone to up to 75 grams per person per day without discussion. And it can even be much higher if you go outside of the US. So those thresholds are mostly found in North American studies, which is already peculiar that you find it in some regions and less so in other regions. The Pure study, which is the up left graph, is a global study, and you see a negative line, which is not significant, but it tends to be a negative pattern if you look at the global data, up to almost 150 grams per day. So even be above those levels, risks are small, and the certainty of all this is very low. And that's because we have observational data that is heavily confounded with very weak associations. On the right side, you see a recent analysis coming from the Global Burden of Disease team, and they concluded that there's a very large between study heterogeneity from 0 to 200 grams per day. So the data is extremely uncertain and very, very contextual, most likely. But anyway you take it, if you look at what is actually consumed on average, even in high income countries, we are below that threshold anyway. So high income countries have an intake level of about 45 grams of red meat per person per day. And that's even below the global average, even if that may sound surprising. And the distribution curve you see here shows you that there's only a very small minority of the global population that exceeds that threshold to begin with. So is this really a global health priority to begin with? And people often talk about risk, but without understanding what risk actually means. Risk is a difficult concept. Risk is not what some people think it is. The risk is when you have a certain hazard, and fair enough, the World Health Organization has classified red meat as a class 2A carcinogenic. But so have they done for being a hairdresser or sunlight. Sunlight is also is even a class 1 carcinogenic. So a hazard doesn't mean much. It has to be combined with vulnerability. Some people may be careful with too much red meat because they're sensitive to iron overload. So they have to mind their intake. But other people would benefit from more red meat because they have iron deficiency. So it is a strong individual dependency. And there's also, of course, the case of exposure. How much red meat, how is it prepared, and what is the background diet? If you look at the table on the left, this is data coming from Canada, where people that eat lots of fruits and vegetables will see that the higher the red meat intake, the lower the development of cancer, whereas people that eat very little vegetables and fruit will see an increasing risk with increasing red meat. So it's a mirrored effect depending on your background diet. Now, we don't know if it's a diet as such that plays or the lifestyles or whatever confounds this, but this is at least a remarkable finding. So taken together, there's an omnivore spectrum, and we may have lots of flexibility in this spectrum, and it may not be impossible to meet our health standards, even without animal source foods, if you go for the vegan option, but it becomes much more risky. The diets become much less robust. I've mentioned the 30% of the calories or half of the protein as somehow a indicative measure. Again, don't take it too strictly because there's diet quality will matter and many other things. But I think we should start stressing more that animal source foods are keystone foods for nutrient security. And there's this minimum amount that we absolutely shouldn't ignore. And a recent major FAO report has made also that exact statement. And then there's the upper side of the spectrum with lots of animal source foods, which is a discussion about too much. But the too much is extremely difficult to assess because it's you have the need to balance harms and benefits, first of all. There's a lot of interpersonal variability. There's contingency in the dietary context. And especially there's a huge uncertainty in the body of evidence. So we don't even know if there is a too much that can be proposed at all. And it would distract us from getting our public health priorities right, which is dealing with those ultra-processed foods and the ultra-processed food culture, whether that's from animal or plant origin. So the question is, and I want to go back to the Dublin Declaration that I mentioned before, the question is, can we achieve this healthy omnivore package for global populations within the environmental constraints? And if we talk about environmental impacts, I think this way of looking at this, the way I present it on this slide is absolutely crucial. An impact is a ratio. You have liters of water or land use or emissions or whatever you want to look at. And then you have a denominator, which is scaling it for the unit of food. That's how we usually talk about impact. And that's a very, very tricky thing to do. Because first of all, what's in the numerator is already complex as such. Are we talking about rainfall water or extracted water? Is it marginal land, or is it land that is in food competition? Is it CO2 from fossil fuels, or is it biogenic methane? There are lots of different discussions here. And we may optimize for one. For instance, we may optimize for lower emissions, but then maybe we'll need more land and you will have different trade-offs. So that's already a very complicated discussion. But the point I'm making with this presentation in particular is that the denominator is also very important. We cannot just talk about kilograms of food. You can do so in certain scenarios if you want to compare different production systems for the same food, but not if you compare very, very different foods. You would have to factor in nutrition, and calories are not enough, and protein may not even be enough because of reasons I mentioned before. And at the same time, taking into account nutrition is extremely important because it's the full basis, it's the entire basis of human prosperity. You cannot have human prosperity on unhealthy diets. Adequate diets are absolutely primordial. Moreover, the impact we're currently facing from metabolic disease is massive, also on the environment. So there's a massive burden of chronic disease on sustainability. The healthcare sector is a huge player in the emission debate. So we should steer away from the reductionism and look at kinds of graphs you see here. So these are the typical graphs you're faced with in media and in policy. This is coming from the World Resources Institute. So you have a list of foods, and then you have the impact. And that impact is land use and emissions. And then you have foods going from good to bad. That's essentially what you see. And then you have beef, which is usually the worst. And you can talk about the size of that bar. So you can say, no, I don't agree with the size because of this and that. And there are many arguments here that are contextual. But also we need to think about the scaling here. This is expressed per calories of food. Now, if this is the message you're giving, and if you're saying emissions are bad and the foods with the lower emissions are the good ones, you end up with sugar and oil and starchy staples, exactly the kind of diets that are leading to malnourishment. So the question we need to ask seriously is whether the higher emissions of some foods can be offset by their higher nutritional value, at least to some degree. And we need to look at dietary patterns rather than blaming some of the individual foods. And if we do that, the saving you have from dropping out, from eliminating your animal source foods is rather minimal, at least in Western countries. On a total carbon footprint, you get a saving of 1% to 6%. Which is not very spectacular. It is something, and you can choose for that, but you have to respect the magnitude of it. And moreover, you would have to maintain that diet all your life if you want to have a meaningful contribution. I'm almost there. I have only 2 slides left. This one here just wants to make the argument that those dietary approaches to sustainability, rather than the single food approaches and the more system approaches, also need to factor in the ecological context. And then grasslands are the thing that we need to talk about. And we often say that livestock uses marginal land and so on, but that's the soft argument. The stronger argument is that well-managed herds, of course, they need to be well-managed herds on grassland also fill in ecological functions, and they contribute to livelihoods and nutrient security. Grasslands are the results of millions of years of coevolution of herbivores and grasses and predators and whatever happens under the soil and all the life you have there, rolling out all over the planet, becoming massive reservoirs of soil carbon and carrying very high densities of herbivores. Those natural densities are very high. And if you would take out our current livestock and we have to bring in back the natural herbivores, and they would come with their own emissions. So essentially, a part of what we are counting now as livestock emissions belongs to the ecosphere and not necessarily to the anthroposphere. They're not necessarily anthropogenic. There's some very interesting recent papers from Pablo Monzano mentioned on the left that I encourage you to look at. And we do often look at the food system as if it were a video game where you can just take out things and unplug and put in other things and just do whatever you want. Pastures are not just to be converted in cropland or in forest land like that, and that wouldn't even, first of all, it may not be ecologically possible or not even be feasible to begin with, but it wouldn't always necessarily be an advantage either. With respect to carbon sinking or with respect to emissions or with all sorts of other things. And nothing tells us that we should see those as separate ideas. We can perfectly integrate all those ideas and combine trees and crops and livestock in more intelligent ways. So to sum up, there are many, many good reasons to rethink the global use of resources and the way we deal with grasslands and how we manage them and so forth. But there's no doubt that grasslands and their intrinsically large herds of herbivores, that those will keep on fulfilling their roles in global ecology, but also in the nourishing of humans, as they have been doing for millions of years. And this is my very last slide. What are the options for the future? Well, you can choose the option on the left side, where they say we take out all livestock, all animal farming, and we replace it with bioreactors. And then just cross our fingers that all will go well. Or you will have the approach on the right side, which is the Dublin Declaration statement that livestock is based on millennial-old wisdom to secure livelihoods and provide nutrients and improve that to meet contemporary needs rather than just starting from scratch and see what happens. And with this, I thank you for your attention, and I'm happy to take any questions if there's any time left.
Questions for Friedrich? Excellent presentation, and brought up a lot of things that I haven't thought about. As I've mentioned, these are being recorded and will be available to participants in several weeks. So any questions? Yes.
Thank you, Friedrich, for your presentation. Could you comment briefly on the current status of something called the global burden of disease? People may be familiar with that, and I think it would be helpful to get your perspective on it. Thank you.
Right. So the global burden of disease is a very important study. It's a report, and it's published every so many years with updates, and it gives an overview of the impact on morbidity and mortality of different risk factors, including some dietary factors. One of the dietary factors is red meat. And so it calculates the impact of red meat, and it tells you, look, so much red meat comes with so much burden. Now, in the past, that was always a risk factor that was reported, but it was a very tiny little factor. And then in a newer version, based on the 2019 data, the small little risk factor suddenly exploded. So the effect was magnified by an order of magnitude, multiplied by 40 times the effect. And they did so because they suddenly assumed out of the blue that every bite of red meat is now harmful. Okay, so every single bite would be harmful, toxicologically speaking, which is a complete contradiction with what the studies show, as I mentioned before. And because of that, we reacted to the Lancet in which the study is published and asked for the evidence and to see why this, what is behind that assumption, because it's not supported by experimental data. And we were not given satisfactory answers. And it generated the whole discussion, and it's still being in process. But it's extremely worrying because we are facing now a global report that is coming with a conclusion that is not supported by the evidence. And if we ask the evidence, we don't see it, we're not given the evidence. But meanwhile, it's influencing policies worldwide, and it's one of the many factors that are contributing to the vilification of red meat as an agent of disease, whereas at the same time, as I argued here, it's a food that is consumed all over our history, and sometimes in much more substantial amounts than we are having today. And the diseases of modernity that we're facing now are in a period of time where we eat much less red meat than we ate in some ancestral populations, where those diseases of modernity were almost absent. So something doesn't make sense. There's a huge problem with data reporting, with data transparency, and it's vital that researchers in the field insist on standards of evidence and on full transparency of the data.
Thank you. And let's give one more question here. Actually, well, let me run over here.
I was just wondering, this might be a little out of your scope, but how non-red meat protein like chicken and eggs plays into that?
Chicken usually comes with neutral effects in epidemiological studies. Again, they tell you only so much, but chicken, the signal of chicken tends to be neutral. There's a lot of discussion on eggs. We had previous messages from a while ago saying that eggs come with cholesterol and so on. And until today, the Eat Lancet report suggests to eat only 1.5 eggs in a week. You know, it's small amounts. The data doesn't show that. The eggs are extremely nutritious. They're really packages of nutrients, and they're extremely powerful, especially in those intervention studies as well, where you have condensed amounts of food full of nutrients that really bring in immediate effects on nutrient adequacy. The chronic disease part is, again, the same story. It comes with associations that are very weak, potentially confounded. And the reason why they're confounded, maybe I didn't explain that, but the reason why they're so much confounded is that people that tend to eat lots of red meat, for instance, where we have a lot of information that people that eat lots of red meat are the people that are just unhealthier. You know, they smoke more, they drink more, they're less physically active. That's just something that happens, especially in Northern American populations. That's why you see those associations much less, or even the opposite, in other parts of the world. And you can try to statistically correct for all of those factors, and they do that in many cases. But you cannot avoid residual confounding. You know, this lifestyles interfere with that, and probably that's the reason why we see different effects in different places of the world. The same as with eggs. You have some associations in North America, and you don't tend to see them in other places of the planet.
Can you use science to change ideology?
Sorry, could you repeat the question? Can
you use science to change ideology?
Well, you should use science. You should especially use evidence, because science is a method, and especially the evidence that is available should be insisted on. That's what we did with the Global Burden of Disease study. We should insist on the evidence. What does the evidence show? How can we interpret it, and what are the boundaries to the interpretation? There's a lot of dogma that is now present, and the nutritional sciences are extremely vulnerable to that. We absolutely need to challenge a couple of the assumptions we're making, and that's in many sciences, but especially in the sciences where the data is not always very sharp. Right? In nutritional sciences, the data is very often blurred because of the difficulty of getting good data. So it's usually not very strong signals we're getting, and then it makes room for interpretation. And then if you enter the debate with certain ideological ideas, and you see that now the nutritional sciences are blended with the environmental debate, and then you have the animal welfare debate coming in, so it becomes one big cocktail. But not because we have room for interpretation, it doesn't mean that we can just state whatever we want. We have to inspect always the premises of what we're trying to achieve and we're trying to say, and check if they're robust enough. That's why I think in the nutritional debate, it has been a step forward to move into quality schemes like the grade system, for instance. The grade system is a system that looks at the quality of the evidence. So not only having an association that doesn't tell you much, what does the association mean? How strong is the evidence? How can we grade it? What is the quality of the evidence? the more we insist on high standards of evidence, the less space there is for ideology. So science comes in different shapes and different nuances, but I think it's especially a discussion on evidence and quality of evidence, and safeguarding sufficient standards of evidence.
We're gonna need to move on, but thank you so much. We need to continue this discussion.
Have a fantastic rest of the conference, and my best greetings from Brussels. Bye-bye.
Bye-bye.